Hello folks, we're going to move on to a set. I can't remember the origin of this, but look, there's no speaker in there. This one's come from, I know this one's come from Alan. This has clearly been outside in the rain for a few years, and I can't really rebuild that. Obviously it's here for spares, but not on the scrap pile, even though it's scrap. So this one's clearly not got a speaker in it, but we can overcome that by putting a speaker in it. I've had to empty a lot of boxes out and kind of consolidate, so I'm now losing track of who's given what. We'll need a bit of a spray on this one. Okay, so apart from there's no speaker in there, I'm not even going to take the bottom off this. Yeah, this is absolutely beautiful condition. So apart from the cases being, I've seen better days. I think this is the early one that doesn't have the meter adjustment for the receive. So let's look at this one. Is this the same? Yeah, it's the same batch. It's November 81, the same. So I bet the serial numbers are close. 8012625 and 4531. So that's nearly 2,000. The ropey one's nearly 2,000 further down the production. What's that? 10 minutes at the max on factory. Good. Right. Well. Oh, what I was looking for, because this is later, has this got the meter preset? No, so it's still early enough not to, which is nice. Gluing back. Right, so our standard replacement mic. We've got the power connectors. We sell those, as you know, but we'll connect it up like this. They're for selling, not for using. And let's power it up. Oh, I'll tell you what, we'll plug the speaker in. Tread carefully. We'll put 9 volts on at the 300 milliamps, and it's lit up. Right, we'll go to full voltage, and the meter light works. Let's just plug let's gear it in. It's receiving as well. And does it transmit? Just put picture in picture on. It does as well. Well, I better pause the video and print off one of our test sheets. Right, we'll run through this then. So transmit, we have got on channel 20. I'll tell you what, let's do this another way around. It's off frequency a bit, not stupidly, but let's just go to the frequency counter and sort that out. So it's 27,79089. It saves putting the signal generator on a different frequency and then back again. Oh, I don't think it's going to go. Well, that's a good start, isn't it? Need to change the reference oscillator crystal. It isn't out. If it was a customer set, I'd say perhaps do it in 5 years' time. But it's not even noticeably out, and it's certainly not illegally out. So I think the best thing to do is just pop this on our crystal tester. I wasn't going to take the bottom off this either. Okay, well the nearest we've got in at the moment is 79101. So we'll come back to this. I'll just make a note of that. I'll just carry on with the setup, otherwise we're wasting time. I can do all this kind of stuff behind the scenes. So we'll go to... I'll just put all these on one side. I've just pinched these out of the other Cobra. Now. Okay, so radio is doing 2.3 watts on channel 20. It's doing 2.3 watts on channel 40. And it's doing 2.2 watts, which is surprising, on channel 1, unless it's just gone down because it's warmed up. So, channel 20, back to 20, and power consumption 1.189 amps, low power 511 milliwatt is slightly high. On the meter, it's reading 6 plus. And we'll now put this in the signal generator. I've been showing you the wrong inlay picture, 79100. We'll just get that trimmed. Just see, I'll go back to transmit. 79108. As it's cooling down and the instruments are warming up, it's getting very close. 108. Well, it's only going to go up, so we'll just go. I'll just take it to 10 if I can get it to that. Yeah. Right, so signal generator. Let's go to the synad meter. Helps if we switch it on. And we'll plug into the synad meter and all that malarkey. If I know where the lead is. Right. So that was S9. Wow, this works alright. It's supposed to be better than 1 microvolt, and this is 0.85. For 10 dB, 0.76. No, give it 7.7. And for 20, if it'll do it, it's 2.4. Tight squelch. Is a ridiculous 7.2 millivolts. I'd like that to come down a bit. And let's go back to the normal speaker. In other words, the one we can hear. And do the normal sensitivity of the squelch. Set threshold on the radio. Signal generator back on. And it's 0.68, so it's very good even with that. being a bit too tight, and on receive is spot on 9. That's actually correct. So that'll be interesting, because when we've done it, it will be different. Is that logical? Yes, it is. Right, let's go to transmit and get through the transmitter. We're not going to touch a VCO. This may have the components fitted to do it. Later ones certainly don't. It can't be far off being pretty central, because it's about the same power across the 40 channels as it should be. Ideally you want it to be within 0.1 between the band ends. So if you've got 4 watts on channel 20, you don't really want it to be worse than 3.9 at one end, and of course 4.1 at the other. I don't think you're going to get done for 4.1. Right. The power's actually set with that other one. This doesn't have any wax in it. This one is not going to do 4 watts. And it doesn't matter. Now what we've got to check, because it says so in the circuit diagram, notice it says 4 watts max. It doesn't say it does 4 watts. But they usually do. So we've done 107, 108, 109, 110, and then L111. The one I say it's set with is 115, but they want you to fiddle with 11 and 12. Oh, we've done 11. 111, 115, 12 and 13 as well, which are these. That's 13 and that's 12. They never want you to touch 1, 2, 4. So 12 and 13 are part of the tune-up. I don't like that, but that's what they are. I'm not playing coil stretching. The placement of where these are is critical. Go through these final ones again. We're just about where we're going to be with this. and that is 3. Just the whole coil, a 32nd of an inch, and it changes it by 200 milliwatts. Right, channel 1, 2.9 watts, channel 40, 2.9 watts. So that's pretty balanced. That will, now the set's pretty warm, when I come back to this it will be higher than that. And remember, this power is on a commercial test set, not on a hobby test set, so it always reads lower than you'd expect, as you know. So low power, we need to adjust that. We need to also adjust, let's go to channel 20, and we need to adjust the power meter, which is the back one there, for, it's saying 4 watts. We all know it isn't doing 4 watts. It's psychological. You set it to 4 watts. We need to do the deviation. While according to this, it's doing 4.2. We'll just check with the test set behind me. See what that's doing. Wow, oh my goodness. I've got this on the 5 scale, haven't I? So yeah, I've got it on the 5 scale, and it's gone beyond full scale deflection. I bet this sounds great on 3 channels at once. Wallow. Wallow. That's it. See what the Marconi test set makes of that. Wow, it's playing up today, isn't it? It's saying it's 1.8. Well, it isn't. So it's now 2. I haven't done that yet. It's greater than 5. 2.2. 2.5 kilohertz. Let's do low power. So I want low power to be 400 milliwatts. It's now we've tuned it to 850 milliwatts. It's preset there. There we go. Actually 410 that. And then back to high power. What current we're drawing now? 1.125. 1.258. I can't even read. Okay, that brings us to receive. So, I'll tell you what, we'll do the PA. So Squelch to the switched position. Testing 1 2, testing 1 2 3. Good. We've got a dirty Squelch, we've got a dirty PA switch. May have to actually put switch cleaner on that. Yep. Turn the power off. There's a hole there in the bottom to put the switch cleaner in. It's lucky I switched it to PA, isn't it? So I'll just work that in. Let's just do it 10 times. Power back on. There we go. PA, CB. PA, CB. Every time. PA switch dirty. Right, we'll go over to the speaker you can't hear. I'll get that attenuation off it eventually. So first of all, we'll go to the oscilloscope and we'll have a look at the waveform and see whether that is the peak for the detector. Oh no. Now that will bring up the 20 dB cyanide, but it'll probably cause the sensitivity to drop. Right, we'll go to the cyanide meter and see whether we can get anything more out of this. So 4 dB, so we're not saturating the receiver, always keeping the signal as low as possible. Well, that was an improvement. So we now would drop the signal again with the attenuator. You get the extra circuit on this. Some of the Maxcoms don't have that coil. I know it isn't a Maxcom, but it's a Maxon. Right, let's get a new reading. See what we've got now. So for 12 dB, we've got 0.71. For 10 dB, we've got 0.61. For 20 dB, we've got 1.8. So it has improved the noise and legibility at the top end there. A little bit more sensitivity. There's nothing wrong with it as it was, and it would have been quite legible. But a little bit of quite a few things there, but it's now right. Squelch. I'll tell you what. Let's look at where the S meter is. It was, if you remember, it was spot on, even though it's preset on these. It's spot on. That's a clever preset meter. But behind the scenes, I'm going to take this front off and run it through our dishwasher and then re-glue it. Good. That's it, isn't it? We've got Squelch to do. That's it. Squelch. So there's the Squelch preset. Let's go back to a speaker we can hear. Oh, we can all hear, because I can hear that one. So I want to be able to squelch out something. That's it, 100 microvolts. And the sensitivity now okay, so now we're back out to answer the phone. We're doing minimum squelch and it's 1 microvolt. I could probably set the squelch more carefully, but that's fine. Certainly under 1.4. So there we go. So I've not got the speaker lids prepared because I'm going to do a respray on this. And right, we're just doing a quick revisit to this. I thought we'd just borrow the output transistor out of that rusty set and see whether it was better, because it has been changed on this one. And oh, that's is that the one? Yeah, that's the one. Gain's 50 on this. Gain on this one's 79. So at least it's not a fake one, so I'm not going to throw it away. You know, when you test these and you suddenly find a gain of 170, you know it's fake, because it's an audio transistor that's been reprinted as an RF transistor. So I've changed the output transistor to a C2078, and I have done a better job than what was done before. We've put thermal heat compound on, which it hadn't got. So I just thought we'll just do another bit of a retune on the transmitter and see where we are. So it was just over the 3 watts before. Let's have a look what we've got now. Whether it's worse. Oh, certainly it's gone beyond the full scale deflection, so that's good. 3.2. Yes, it's now 3.2, so there we are. Just check it is on the other channels. Yep. So I'll amend that. So that is now 3.2. That is now 3.1, and that is now 3. Let me just check load power. Yeah, that's now 450 milliwatts. We need to drop that a fraction. There we go. Right, so I've just given the cases a quick blow over. I've put the front through the dishwasher, glued back the escutcheon, which was coming away at this side. We use Bostik adhesive. Have I got one here to show you? Yes, I have. That one. It's the only one we recommend because I experienced with that on certain parts of organs. Those parts which aren't the traditional parts. And we've just turned that off. And I'll just strip these. So we don't have a speaker and we don't have the fixings. Now you can put nuts, bolts and washers to overcome that problem with the fixings, but I know we've got an illegal AM set, and fingers crossed, because it's the same make, well, it's come out of the Maxon factory. It should have the right fixings and be the right speaker. So I'll just pause the video. So it's a Midland 3001, it turns out to be. At least it's got the knobs on it, and there we go. So you can see it's an American one. It's got the FCC plate. It has the 3-pin Uniden type connector instead of the type that's used on the UK sets. July 1979. It's about time it gave up its speaker. So these are contraband, so you can't legally own one. So this is a problem because they have to be destroyed. So we've got the right speaker, the right fixings. It's the same maker's set. These are made by Maxon. So hopefully that will go straight into the lid. So the best thing to do with these, because there's quite a lot of useful parts, we couldn't recover this type of output transistor for this type of set because, just like with the audio chip, they've gone through the printed circuit board and not over the edge like they have with the UK ones. So the best thing to do with these, rather than totally ruin it so we can't use any of the parts, is actually to ruin it so that it no longer is possible for it to transmit. So I'll just get rid of that bit of wiring there. If we get the modulation transform with some pliers and actually break it out of the board, that is never going to work again, and that's the idea. This can go in the bin. So we're not testing it, but useful lots of parts that can now go on a scrap pile, and it's considering there's no difference apart from the fact it doesn't say CB2781. Even I've bought a Midland 2001 once, which was an AM one, which could of course never been sold in the UK. So I've got a Midland 2001 on the shelf with no knobs. So this is going to be a good candidate. Chances are the meter works. So now we can recover this speaker. I'm going to keep this lid. That feels all right. I'll keep the lid because that should be okay. Right, I'll go and find the newly quickly sprayed over case.